like you to think about how your ideas, what you heard other groups say. So maybe some other groups said something in their explanation that you didn't think of, you and your group didn't think of. So you can look to add that to your ideas. Or you can think of, if you don't remember anything that another group said, you can just think, how did your ideas change from when you first saw the tanker crush to now?
Cool.
Let's get started. As I walked around, I saw a lot of you had some new ideas about pressure. A lot of you talked about pressure. And a lot of you were talking about air outside. Some of you said you learned some new things about temperature and compression and the molecules. And so before we continue today, we're going to continue gathering information, trying to figure out how this tanker crushed. But before we do that, I'd like to look back over your posters from yesterday. So we're going to look at the posters and kind of make a list of what's causing the tanker to crush based on your ideas. And also, I want us to start looking, does anything seem to be linked together? So does one thing happening in the tanker seem to cause another thing to happen? Okay, so as we look through this, that's what we're going to look for. So let's start with this poster. I think this group, they showed us here molecules moving around. So I think this one did a really good job of showing us those molecules moving inside the tanker. And then they said, as it cooled down, what happened to the molecules? This group,
Slower.
They became slower. And so they showed us that those molecules slowed down. They also showed some air outside. They're thinking about the air outside of the tanker. And they show us that what happens then to the air molecules in this one right here. Maybe they stopped, or you're right, they're not showing us that they're moving at all. But we know that molecules don't ever stop moving until they get to absolute zero, but they're moving more slowly and they're compressed. Okay, so they're really thinking about how temperature is affecting the molecules inside the tanker. Let's see. This one and this one. Took that a little bit further, and they talked about how temperature affected the gas. And can you see what they're showing here? What happens to the gas when it got cooler? What do we see forming here?
To liquid.
Yeah, so it's actually having a phase change. We're getting liquid water collecting at the bottom of the tanker. Look, they're showing us here, are there any more gas, water particles in this tanker, in this picture? No. They said it's all turned to liquid. So they have this idea that it started all as a gas, and then it started to condense and become liquid, and then eventually we got all liquid. And this group kind of started to think about that too. They started to think about this, this orange is showing that it was a gas, and then they didn't draw it yet, but they talked about this being water at the bottom of the tanker. And then some groups started to think about pressure and the molecules moving around. So this group shows the molecules moving. Here they're showing arrows, and they show these arrows going out, showing that there's collisions going against the edge here of the tanker. So they're thinking about that pressure that's being created by the molecules moving around here. And then they said as it gets colder, the molecules start to slow down. So again, they're talking about speed of the molecules. And then they talk about pressure here too. And they're also trying to think about these air molecules outside the tanker. So they have little drawings of air molecules here, and they're showing arrows of that air pushing against the tanker. And they're thinking that that air is just pushing down on the top. So that's something that we can think about. And then this group also talked about pressure, and this is the one where they said they kind of imagined that this air around the tanker is like a giant foot pushing down on it, on the tank. And can this group remind us why was the air foot able to crush this one and not this one?
Because the first one with gas in it, the gas was creating pressure up against the walls of the tank, and if it was turned into water, the tank probably wasn't having as much pressure put upon the sides of it,
Okay.
so it probably was easier for it to crush.
Okay, so something about a difference between what was inside here versus here, which allowed that pressure outside to have different effects between this one and this one. And I think that this group also showed us that. They said the pressure inside became less than the pressure outside, and so it allowed it to crush. So we have all these ideas that we're working on, and so we have some idea of temperature. What did temperature, tell somebody next to you, what did temperature seem to affect inside the tanker? Tell somebody next to you, what did the temperature seem to affect? Okay, so what did it seem to affect?
The tank and the outside.
Molecules inside.
What about the molecules inside? Okay, so temperature affected the molecules. What about the molecules?
They either slowed down or got faster.
Okay, so it affected speed and phase. And we also talked about some pressure here. Pressure inside the can, or the tanker, and pressure outside. So the pressure inside, what does that link to? What? Tell somebody next to you. What is pressure inside? How is that affected, or what caused pressure inside of the can to change? Tell somebody next to you. What caused the pressure inside of the can to change? So something about the pressure inside. Which ones of this showed us the pressure of the molecules inside the can having an effect, or inside the tanker having an effect?
That one.
Which one? This one? Okay, and what did they say about what caused this pressure against the walls of the... Vernon? What caused the pressure here?
The steam.
So something about the steam, and so pressure inside caused by what?
Steam.
Caused by the steam.
It kept the shape.
Okay, because gases take the shape of the container. Okay, so I want you to keep thinking about this. What's causing that pressure inside? And how about the pressure outside? What did the pressure outside have to do with this scenario? Who showed something about pressure outside having an effect on the...
Isn't it gravity?
Okay, so
Justin's group, the pink paper.
this one talked about, you talked about, the pink paper did show air outside, and so did this group. Did you guys talk about air out here? And I think there's one more. This air foot was kind of an idea of pressure outside. So what does the pressure outside do to the tanker, based on what some of your groups have talked about? Okay, so
Come in.
it crushes the tanker. And I want you to just continue thinking about this. Why would it crush the tanker? Why does it have the ability to crush it? Because it's not getting crushed here, and it's not getting crushed here, right? So we're going to continue adding to our ideas here as we continue today. And you have tongs to touch the can, so don't touch the can with your fingers. You're going to put it on the hot plate and turn it on, and you're going to wait until it starts to boil. You'll see steam coming out, and you'll hear it boiling. And let it boil for about a minute. Then you're going to, wearing goggles the whole time,
That's great.
you're going to take your tongs, pick up your can, and you're going to flip it over with the top part into the plastic, okay? So what do you think is going to happen?
I think it's one that it's one of them.
Tell somebody next to you, what's going to happen when you do that?
It's gonna do like the tanker did. Yes.
Oh yeah, it
So thank you.
The temperature was forced to change.
Okay, so what do you think is going to happen?
It's gonna grow.
Okay, so I hear some people saying it's going to crush or implode. Why would it do that?
Are we covering the top?
Okay, so you what? You can't tell? You don't know what's going to happen? Okay, you know it's going to crush. You've seen it before, but you don't know why. You think We're changing the temperature. We're boiling it and then we're putting it in cold water.
Oh, I think it might like to slowly just like stick it in, not like squish it.
Maybe. Tani asked a good question. She said, are we going to seal the top of the container? So when we take this can and we flip it over, what are we doing to the top of the container here? You're going to be covering it. So you're going to keep thinking about that. And I'm not going to show you what's going to happen. I want you to do it yourself, okay?
Oh.
So,
Watch out. Is it on?
Yeah, no it isn't. Put soda on a hot plate and then turn the hot plate on.
It's gonna cause a reaction.
what kind of reaction?
Cold and hot reaction, which caused me to implode, I guess.
Okay.
So it has
So,
no air, so
what has no air?
when you put it in here,
What do you mean it has no air?
it won't be getting any air.
Okay, so air can't get in. So how does that affect it, do you think?
Well, just like our theory, air's trying to get in there.
Okay, so, all right, so you have your can and it's flipped over. And what do you mean by air's trying to get in?
Well, since it's cold, the temperature of the water should cause it to be cold, and I don't know, actually.
Okay. So I want you to keep thinking about that. Think about that air, and you're describing it as it wants to get in. But I want you to keep thinking about, like, what is that air doing on the outside of the can?
Okay.
So you can start doing number one. You need to start by drying the pop can. You can start by drying it at stage one, the dry pop can with 15 milliliters of water in it.
Does anybody else want to do the water thing?
You mean when you put it in the water?
I do.
Good.
We're about ready to.
Yeah, there you go.
Flip it over and
And then stick it in there.
Oh.
That's cool.
Oh, that's good.
that is awesome.
That was so cool.
What happened?
It sucked it in.
Instantly, like,
The water went.
Okay, so let's talk about what's happening here. You have your first can here,
What just happened? You already did.
and so you should be showing me what's in the can and draw the molecules of gas inside the can.
It's barely warming up. Turn up the
So I see in Tani's picture she has some water in the bottom.
Ernie,
Is there any, what else is in this can?
Pop. Like little.
Okay, so maybe there's a little bit of pop. And what else is in there?
caught on. This is reality.
What's in this? Yeah, so there's air in the can
This is
too.
reality. You're gonna hear that. When they play with the video.
Okay. And now it's on the, you have it on the hot plate here. What happens is you're heating it up. The steam's coming out. And so can you show me draw the molecules of gas inside the can and show me what they're doing? Use arrows to show the movement of the molecules inside of your can. So how are these, right now these look to me like they're just sitting there. Are they moving? They're not moving?
They're moving.
What's moving?
The little molecules. Remember how they heat up?
Yeah,
They're
it's
always
moving.
bumping around.
How can I tell by looking at this that they're
You
moving?
have to have arrows.
Oh.
Good.
You should put like ice water in it first and then seal it up somehow. And then put it
know
on a
what?
hot plate and let it boil.
You know what I just realized?
What?
There wasn't that much water in it, but when you turned it upside down, it didn't float back up like it does now.
sucked in
It was down like this. It didn't suck in water.
It is down like that.
No, I mean, okay, I had water in it,
Oh.
but when we first put it in, there's only a little bit, and usually if you go like that, it'll stay up and it won't go down.
No, but it did suck the water
It did
because it went
suck some water
it went-
in.
Why would water go into the can, do you think?
because of the pressure.
The pressure sucked it in.
Negative pressure.
The cold air sucked it in. Or
The negative pressure
What do you mean by that?
is pressure is not pushing it out, it's sucking it in because it's negative.
how could you also explain negative pressure, thinking about like comparing two pressures? Because that might help you think about what's happening on the outside of the can too. So think about comparing pressures.
We should do this one.
You can. You can do that one as you work on the next ones, because I want you to think about, especially, I heard Cullen starting to think of some ideas. I want you to think about the can crushing and like, what do you wonder about how you could change the experiment? Like, what do you think might affect how much the can crushes? Or what do you think might affect the behavior of the gas in the pipe?
What do you think was different between the can and the tanker?
What's
Look how,
different size?
remember how she said the tanker was overnight, so it happened in a longer period of time. The video was
bigger,
different.
The can is being, the reaction is
immediate.
quicker is because it's being heated up.
Okay, so the temperature changed quickly. Why did that cause it?
Like if we change like the water, like if we didn't put water inside until after and see how it
So if you didn't put water,
like not like a lot of like that much water, like a tiny bit, and see how it would do that and like the temperature of the can.
okay, so you think you could maybe change the temperature of this, and then also how much water you put inside the can. Okay, so then you're going to be thinking. I see you already started here. So you think water might affect. What do you mean about water? The amount of water?
Yeah.
So the amount of water might affect the can because.
I still haven't got that far.
Okay. So what do you think? How could changing the amount of water inside that can affect it?
Maybe how much water you
Is it possible that it would crush it more or less
If you did what?
if you add a different amount of water to the inside of it?
Okay, so let's take one example. We put less water inside of it. What do you think might happen?
Probably wouldn't crush as much
As much? Why?
because there's less pressure inside, there's less pressure change.
Okay.
Maybe because there's less steam, because there's less water.
Okay, so maybe if there's less steam, it would crush less. And then what about if you put lots of water in here?
I don't think it'd crush that much if you put a lot of water.
Why?
Because it has to like, I just don't think it would.
I think you have a good idea. Why do you think it might not crush as much?
Because you got too much like pressure inside.
Too much. And
Like
what?
too much water
Okay.
for it to do that. Because I know if when you squish something, it pushes it out.
Okay. So something about the water in there might be too much.
It'd be too full.
Oh, maybe it takes up too much space. Okay. So those are the kinds of questions or statements I want you to make here. Okay. So you can say, I think the amount of water might affect how much the can crushes because, and explain why. Good.
I'm scared.
So,
How can it crush that much? Oh, less water, more strong. Yeah.
Compare the cans. This one.
How much you guys
crushed
put in
more.
there? This is only 50, right?
This is the 40,
was
this
40,
is
this
this
was
is
15.
15.
Oh, 15.
So the
This
less, the
one
more it
crushed more.
crushes.
So the less water it crushes more.
That's crazy.
Can you think of anything else you could change about what we did here that might affect the can?
Colder water.
Colder water? Where? Okay. So I'm not sure if we could make this much colder, but what if we made it just without ice? What do you think would happen then?
Crush as much
Why not?
because it's not really cold. I guess this has to be really hot. This has to be really cold. When they touch each other, I guess they try to communicate with each other, but they can't. So it's like negative.
Okay. So let's think about you. I heard two things here. I heard one about the temperature of the can, how hot you make that, and then I also heard the temperature of that. So you could do two things. You think that I think that the temperature of the water, the ice of the water bath, could affect how much the can crushes because, and then tell me why you think that. And then also you said something about the temperature of inside the can. So maybe I think that the temperature inside the can, or maybe how long it boils, would affect it because, so that's what you're going to write here, okay?
So what happened right there, would it affect on like a plastic bottle?
Oh,
Like
so
a Pepsi
also,
bottle?
okay, so maybe,
You know, does it have to be metal or aluminum?
okay, that's also a great question. So go ahead, and you can write that question here too, or here. So here's your questions. Here you're going to actually try to think about why your questions, like how it might affect it. So you might say, does the kind of material affect it? And here you would say, I think the material does affect it because, and explain why. Okay.
I'm not sticking it. For the question? I said I think that the amount of water put into the can can affect how much the can crushes because of the pressure difference or change inside and outside, as well as how much space the water takes up.
Okay, so tell me more about that, how much space the water takes up part.
I know if we put like we said before, if we put a lot of water, that's not gonna crush as much because we measured that can to that can, and we put 15 in this one, and it crushed more.
No, we put 15 in that
Oh.
one, and we put 40 in this one.
Oh, you put more in that one?
Yeah.
Okay.
If you
So
look
you
at
already did a little experiment here.
If you look at them, which one was this one was crushed
15. More.
more than that one.
Okay. So you've already done it and you see a difference. So what are your ideas about why that one didn't crush as much?
Because we put more water.
Okay, so you kind of see that the amount of water affected it. And then I heard you say there's maybe two things going on. What and what? Pressure difference?
Space.
So space. And so if there's more water in here, what does that do to the space?
It takes up too much.
There's less space for it to
Impact.
Yeah. But the,
implode.
Oh. So the water's like already taking up space for the implosion. Okay. And then you also think that water has something to do with the difference in pressure. So think about, in your reading last night, you read something about the behavior of gases and their compression. So you want to continue thinking about how that, like compression of gas versus how much you can compress water. Think about how that might affect your results. Okay, and so it says, make sure to draw the molecules of gas inside the can. Use arrows to show the movement of the molecules. So this is the beginning one, and this one's on the hot plate.
Close the door.
So is there any gas in this can right now?
Not really, no. Because the liquid's just liquid right now. So then it's at the bottom. And it's not being heated.
So what's in this space of the can?
It's air.
Air? What is air? Is air a solid, a liquid, or a gas?
Gas.
Okay, so we have water and we have like oxygen or our air molecules that should be in this part of your can. So how could you draw those in there?
Small circles or?
Yeah, little, just this particle.
A little particle can be the air.
Then I want you to continue thinking of what's happening now when it's being heated up, what's happening inside the can. Okay? Okay, so I heard you guys debating about whether or not this was sealed or not sealed. So tell me more about that.
It's sealed.
Okay, so why is this, how do you know it's sealed?
Because we put it on
I was just saying that this sounds
that
smart.
top head.
Okay, so you put it the top down. Okay. So tell me, what do you think, why did this happen?
We're still deciding on that.
Okay. You might want to pick up this can, see what happens.
Pick it up?
Yeah, just
Or
pick it up.
explode it?
And kind of dump it out. Do you think the amount of water inside that can changed?
As it boiled or as
No,
it
when
went
you
in
flipped
there?
it up, like right now, was there more water in this?
No.
Okay, so it didn't change.
Maybe.
Okay. Well, that might be something
Because
to
if
think
it
about as
was
you do
in
this
there,
one.
water would flow in there.
Why would it flow in?
Because it's open.
Okay. So let's, you can maybe think about that. But let's think about why this crashed. Because I see a picture here, I see all sorts of movement of molecules.
That's weird though.
What's weird?
How does the air get out? How does the pressure of the air get out?
So what's inside the can in your picture right here?
There's air and water.
Air and water? Okay, and so then when you flipped it over, what'd you do to it?
Oh, wait. I didn't take all the air out though. I mean, there was still air and water when I flipped it over.
Okay, so this air and water is still in here. What happened to it? What do you think?
Mm,
Did you take anything out of the can when you flipped it over?
No. No.
Okay, so what happened to the stuff inside there?
The water started coming down.
Okay,
The
so
hot water.
what?
The boiling water.
The boiling water went.
Came out as you put it in.
It didn't come out, but it was coming out though.
Okay, so the hot water was down here. You flipped it over. Now it's down here. What else happened?
It got crushed.
The water
Oh.
gets released.
What?
The water inside the can.
Okay, so maybe some of the water came out. Is the water? And then, what else do you think happened?
The cold water and hot water touched.
Okay.
Mixed.
And
The reaction thing.
so when cold water and hot water touch each other, what happens to it?
It spins, creates.
It's just like a tornado.
How could that affect? How could that make the can crush? I want you to think about these gas molecules. So where you have these gas molecules moving around inside of there, and they're moving all over. You guys see some big arrows, and then you flipped your can over. What do you think happened to those?
What happened to it?
Yeah.
Are
Are they still?
Liquid.
They're still in there.
Oh, so maybe they could have turned into liquid a little bit.
Yeah.
Why would they have turned into liquid?
Steam. They got cold.
Okay, so they got cold and maybe they condensed into liquid. Okay.
Oh, I see.
So how could that make it crush then?
Less. Oh, because there's no air no more, causing it to turn into water and you're making it cold.
Okay.
I don't know. It's confusing. It's confusing to say.
Yeah, it is confusing, but you can keep working through that. You guys have lots of good ideas, so keep trying to work through it together and get your third can drawn.
So it turns water and it brought the can with it.
So the
Turn it
steam
over,
and the water
When you
mix.
turn it over, when the steam, the water went down, and the steam
Like brought the can with it.
brought the can with it.
What if I only put like
It was something that made it crush. I'm saying that the steam that turns water brought the can down. That's how it crushed it.
That sounds reasonable. Alright, cool.
So, and you can do why you think the can is crushing too, but I want you to start thinking about what do you wonder about this? Like what parts of the experiment could you change? Is there anything that you think like might affect the can or could maybe make the can crush more or less?
The amount of water in the can.
Okay, what about, how could that affect it?
Because we only put 15 millimeters, so maybe it'll probably crush more if we put more water,
Why?
more steam.
Okay, so why do you think more steam would make it crush more?
Because it also causes it to have less air inside the can.
Okay,
So it causes the less air, the more it'll squeeze.
okay, what do you think about that? What do you think about that? If we put more water in the can, would it crush more or less?
I think it'll be less.
Why?
So what we did is we put 15 milliliters of water inside the can. We heated it up on that.
There'll be like less steam
Okay.
because it's kind of small, and with more water, yeah, there wouldn't be that much steam.
So if you put more water in here, you're saying that it would change actually how much space was available for that steam to take up.
Yeah.
Okay. So that's the kind of thing you're going to write here. So you're going to say, I think the amount of water might affect how much the can crushes because, and then say why. And so your idea is that it would give it less, more or less amount of space for the steam to take up. So that's what you're going to write in this box. Yeah.